Hello, everybody. My name is Akanksha. I did my PhD from IIT Bombay in mathematics, and currently I'm serving as an assistant professor in Manipal Institute of Technology. So, regarding in today's video, we are going to talk about conditional probability. What is conditional probability and all? I'm going to tell you in details, and that to be very basic level so that you all can understand the concept easily. But before conditional probability, I would assume that you already have a familiarity with basic probability, which we discussed in the last class. So, if this is the first video on probability you are watching, then I will highly recommend you to go and first get some familiarity with probability, basic probability, because then only you will understand conditional probability, because it is a bit of intermediate topic. So first it is necessary to understand probability. So in this video, firstly I'm going to tell you what is conditional probability at intuitive level, and then we will solve some problems, and we will see how you can compute conditional probability, what does it mean, and at the end I will give you some problem for practice. So let's get started. So, first of all, what is conditional probability? So, in a layman language, as you can see, it is written over there. Conditional probability is the probability of an event happening given that other event has already been happened. What does it mean? So, before going into the formula and notation, let me tell you what does it mean. So, as you know, my favorite example in probability is coin example, because we all are familiar with coin. So now just try to assume one situation that you are tossing two coins, or you are tossing one coin twice. Okay. So you know that coin has this structure that one side a coin has head, other side it has tail, right? So now assume that if you flip flip this coin twice, okay, twice means two times. If you flip a coin, what will happen? Tell me. So you may have four possibilities as outcome. You may have H, right? When your coin will land on heads both the times. You will have, you may have H and T. You may have T with H, and you may have T with T, right? These are the total possible outcomes you have, right? Now, if I ask you to calculate probability of getting heads and heads, means twice heads, how many times in this you will have heads and heads? Only once, right? So 1 upon 4, because total outcome is 4. This is your basic probability. Basic probability. But now, what is conditional probability? Conditional probability is, assume that some extra information is already there. Let's say somebody told you that given first coin, okay, because you are tossing the coin twice, no? So let's say given that first coin lands on heads, okay. So somebody has already given you the information that the first flip you already got head. Now how many possible outcomes are possible? Because already heads is there, so HT and HH, right? These are the only two outcomes are possible now in the flip, in the flip of two coins. Now if I ask you what is the probability of HH given first coin, okay, let me erase this, lands on heads, what is the probability? Again, HH you have only one, so 1 upon 2. So that is the difference between Basic probability and conditional probability. You got it? Conditional probability. So basically, conditional probability means you already know something, some additional information about the event. So in this case, you can see that over here, the difference between these two. In this case, you are just asked to compute probability of getting heads. That's all. So you know that if you flip a coin twice, you have these four outcomes. Now in this case, in second case, you got to know that first coin which you flip already lands on head. So these two cases will never happen, right? So now your sample space is just two two events. So conditional probability of having HH given that first coin lands on H is just 1 by 2. So that is what is written in this slide. Now try to read this line again. So what it says, conditional probability is the probability of an event happening given that another event has already happened. Okay, so you already knew that first coin lands on head. Now tell me the probability of HH. So that is the scenario. Now notation and formulation. So the conditional probability of an event A happening given that another event B has already happened is written like P given A. So we call it, oh sorry, A given A. So we read it as probability of A given B. Okay, and it is given by probability of A intersection B divided by probability of the event B. Okay, that is what we did. So probability of A intersection B divided by probability of B. What does it mean, A intersection B? This already we have discussed in our first introductory lecture. So set theory, some basics of set theory you need when you do probability, and that also we have already discussed. Okay, I hope now you have a bit familiarity. Now, as I told you, so P given A means probability of A given B has already happened. What is this P? This is P intersection B is the probability that both A and B happen together. Probability of B is the probability of event B happens. So these are some notation and how will you read it. Now let's see some example. So first card example. If you are not familiar with cards, that also we have discussed in our last lecture. So a deck has 52 cards, and out of 52 cards you have 20 red and 20 black cards. Diamond are there, 10 diamond are there, 10 hearts are there. So again I would recommend you just watch previous video. So now let's look at the problem. So what it says, a deck of 52 cards has 4 kings, right? This is like standard thing. If you randomly pick one card, the probability of getting a king is, so you know that probability of getting a king is, you have 4 kings and total 52. So 4 by 52. Now this is the second scenario. Now, if you already know that the card is a face card, okay, face card means it could be king, queen, or a jack. The total possible face cards are, we know that we have 4 king, 4 queen, and 4 jack. Out of 52 card, we have total 12 face card. So if you already know that the total possible face cards are 12, so the probability of getting a king is 4. So here, probability of getting a king given that your card is a face card means somebody has already told you that the card you have picked is a face card. Now tell me what is the probability of getting a king. So obviously probability will increase now. See there, if somebody asks you just pick a card out of 52 and what is the probability, what are the chances that that card is a king, again The chances are very less. But if somebody has already told you that the card you have picked is a face card, now tell me what is the probability of a king? Obviously, probability is higher. So, total face cards are 12. Now, total kings are 4. So, 4 by 12. So, in this case, you have probability as 1 by 13, and here it is 1 by 3. Right? Since we already know the card is a face card, we only consider face cards while calculating probability. So, conditional probability means you already know something more about the experiment. Then somebody asks you to calculate the probability. Let's see next example. What is next example? It is a rolling die example. So a fair die is rolled. So it is a six-faced die. Okay. So when you are playing Ludo, that dice you use, na, that die we are talking about. What is the probability of getting a A4 given that the number is even? So what is asked? It is asked that probability of getting a 4 given that even, given that the number is even number. So this probability you want to calculate. So S, sample space, means if you roll a die, how many possible outcomes are there? 1, 2, 3, 4, 5 or 6, right? These are the possible outcomes. Now, how many even numbers are there? Right, even numbers are 2, 4 and 6. Now, these are the even numbers. So, now what is the probability of 4 given E? Means, what is the probability of getting 4 when the number you have rolled is an even number? So, it is just 1 by 3. Why? Because 4 is just single number. So, favorable outcome is just 1. And what is E? Total even 1, 2 and 3. So, basically probability of, so if I go with the formula, probability of 4 intersection E divided by probability of E. Oh, sorry. Yes. So, what is the probability of 4 intersection E? So, it is just 1. Right? Is 1. And what is the probability of E? It is 1, 2 and 3. So, total outcome is 3. So, 1 by 3. Let's look at some more examples so that the situation and the scenario will be clear. So, here we have a bag example. This bag example already we have discussed when we were doing this basic probability. So, in a bag, you have 4 red marbles, 3 blue marbles, 5 green marbles. Okay. So, total how many marbles are there? You have total 12 marbles are there, right? Total 12 marbles. Now, what they have asked, one marble is drawn. Okay, you have picked one marble and that is red. You already know that red marble you have already picked. What is the probability that the next marble drawn is also red? So, you have to calculate the probability of picking a red marble given red marble. So, probability of uh, drawing a red marble, given that one red marble you have already picked. So, what is the probability of red marble? Picking a red marble, it is, how many red marbles are there? You have 3 red marbles. How many total marbles are there? You have 12 total marbles. So, this is the probability of uh, picking a red marble. Now, what is the probability that the next marble drawn is also red? So now, after, so basically, after picking a red marble, what is the situation in the bag? We have Oh, how many red are there? Oh, red was 4. 4 by 12. Sorry. We have 4. We had 4, na? So we have 3 red and 3 red marble, right? We have 3 red marbles. So, what is the probability of red given red means you already know that one red marble you have already picked. So, now you are left with 3 red marbles and total marble you have are 11. So, it is 3 by 11. Okay, because somebody has already given you the information that you have already drawn one marble and that marble was red. So, you have only 3 red marbles now and total marbles are 11. So, 3 by 11. Now, again, a rolling dice example. Two fair dice are rolled. So, two 6 face wala dice are rolled. Given that the sum is greater than 9, what is the probability that at least one die shows 6? So, here we are talking about sum of both outcomes is greater than 9. Let me denote X as first outcome and Y as second outcome. Is that fine? First outcome and second outcome. So you have to look for X and Y so that X plus Y is greater than 9. So we know that if you roll two dice greater than 9, how many possibilities are there? It could be, oh sorry, it could be 10, right? Greater than 9 means 10, 11 or 12. That's all. Because if you sum the outcome of two dice, it will start from 2 and it will highest it can go till 12. So in how many ways you can get 10? It could be 5 with 5, right? It could be 4 with 6. It could be 6 with 4. So 3. 3 total. 11, you can have 5 with 6 and 6 with 5. So total possibility are 2. And for 12, you have 6 and 6. So only one possibility. So they are asking what is the probability that at least one die shows a 6. So total possibilities for the sum greater than 9 are how many possibility? 3 plus 2, 5 plus 1, 6. Okay. And out of these 6 possibilities, what is the possibility of at least one die shows 6? So here you have 1, 6, 1, 6. Here you have 6, here you have 6, here you have. So at least one die should show 6. So you have 1, 2, 3, 4, 5 possibility. So finally, you are asked to calculate probability of at least 1 6 given that sum is greater than 9. So total possibilities to have sum greater than 9 is 6. And how many out of those 6 possibilities, how many possibilities has at least 1 6? 5. So this is the answer. Is that fine? So total possibilities of sum to be greater than 9 are 6, and out of those 6 possibilities, how many cases in how many cases you have at least 1 6? So 5 cases. So probabilities of at least 1 6 given sum is greater than 9 is 5 by 6. Next problem. In a class of 60% of students play football. So, in a class, you have probability of students playing football. That I will be denoting by probability of F is zero point 0.6. As I told you, probabilities are always between 0 to 1. Let me write it as 0.6. And probability of what is given? So in a class, 60% of students play football and 40% play cricket. If 30% play both, what is the probability that a student who plays football also plays cricket? Okay, so P of students playing cricket. That I will be denoting by P of C. Is that fine? So that is 0.4. These are the probabilities. And somebody told you that 30% play both. Means probability of F intersection C is given to be 30%. That means 0.3. Both means students which plays cricket as well as football. So probability of F given C intersection C is 0.3. Now what they are asking? What is the probability that a student who plays football also plays cricket? Probability of student who plays football also plays cricket. So cricket given football. So just have a look. What is the probability that student who plays football, that is already given that a student plays football also play cricket. So you are asked to calculate P of C given F. How will you calculate? It is probability of F intersection C divided by probability of F, right? What is the probability of F intersection C? It is 0. It is 0.3. What is the probability, total probability of F football? It is 0.6. So you will have 1 by 2. This is your final answer. Is that fine? Next, a bag contains 5 red and 7 blue ball. So 5 red and 7 blue balls, right? One ball is drawn and found to be red. Okay, what is the probability that the next ball drawn is also red? Again, same type of problem. So probability of picking a red ball is, how many red balls are there? 5. How many total balls are there? 5 plus 7, that means 12. Now you are asked to compute probability of red given red. Means you have already picked a red ball. What is the probability that next ball will be red? So now how many balls are left there? Only 11, because one ball you have already picked. How many red balls are left? Only 4. So this is the probability. This is the probability they have asked. You are asked for 4 by 11. Next, a fair die is rolled. Okay, again a die example. So you already know that if you roll a die, the total possibilities you have is 1, 2, 3, 4, 5, and 6. Now a fair die is rolled. So sample space may you will be having 1, 2, 3, 4, 5, and 6. Given that the outcome is an even number, already know that outcome is even, right? So E, let me denote it by E. Outcome is even, that means 2, 4, or 6. Only these are the possibilities for the outcome. Now, what is the probability that it is a 6? So, probability of a 6 given E. So, probability of 6 given that the outcome is even, you have to compute. So what is the probability of, let me use the formula, 6 intersection E and probability of E. So now you know that probability of 6 intersection E. How many? So 6 and E, you have only one case. So 1 upon 6, right? What is the probability of E? How many even numbers are there? It is 3 upon 6 because total is 6. So it is 1 upon 3. So basically, the probability of getting a 6 given E is 1 6 divided by total even number, that is 1 by 3. So you can use your formula or you can use directly that you just count. 6 is just 1 and how many total are there? 3. So up to you. Next, card example. A card is drawn. Oh, this question we have already done with. Okay, a card is drawn from a deck of 52. Given that the card is a face card, what is the possibility that it is a king? So we have 4 king in a deck of 52 cards. Okay, and we have total 12 face cards. Now what is asked? It is asked that probability of a king given that it is a face card. That is what you are asked for. So if I use the formula, it should be probability of king, a king intersection face card divided by probability of this given event, face card. Let's see how will you compute this intersection wala probability. So probability of king intersection face card is, so how many face cards are there? 12. How many kings are there? Only 4. So probability of k, 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 k. These are the 4 kings and 12. You have 12 face cards. So the intersection of these will be k, k, k and k, right? Because these 12 face cards are having 4 k's, 4 j's and 4 queen. Right? These are the 12 cards. So it is just 4, 4, 4. So what is the probability of getting a king? It is 4 upon 52. Now, what is the probability of getting a face card? Face card. So how many face cards are there? As I already told you, it is 12. How many total cards are there? It is 52. So now if I plug these two things into the formula, what will you have? You will have 4 upon 52, that is the probability of intersection, and 12 upon 52. So 52 and 52 will get cancelled. You are left with 4 upon 12, that is 1 upon 3. So this is your final answer. So how many face cards are there? 12. How many kings are there? 4. So 4 upon 12. So you can use your formula or you just count. Up to you. Next problem. 2 fair dice are rolled. Given that, okay, again, 2 fair dice are rolled. Given that the sum is greater than 8. So, again, let me call X as first outcome. Outcome. First outcome. Let me denote first outcome by X and Y as second outcome. When you are rolling a dice. So the condition is X plus Y is greater than 8. So you are asked to calculate probability of showing up at least 1 5. Let me write it completely. Or let me write it in a different way. So let me define A as an event that at least one die shows a 5. That is event A. Let me denote event B as x plus y is greater than 8. Now you are asked to compute probability of A given B. So for that, you have to see how many possible outcomes will give you 8. So let's see. So x plus y greater than 8. So let me write x over here, y over here. Let's see. So sum should be greater than 8. So what all sums are possible? It could be 9, 10, 11 or 12. You have to count cases when you get 9, 10, 11 or 12. So let me start with 9. So for 9, you can have 9 with 3 and 6, right? 4 and 5, right? 5 and 4, then 6 and 3. So these are for 9. Second, 10. You can have 10 as 4 with 6, 5 with 5, then 6 with 4. These are the three outcomes for 10. 11 के लिए you will have 5 with 6, 6 with 5, right? And then 12 के लिए 6 and 6. So how many total cases are possible if somebody asks you that the sum is greater than 8? It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So sum is greater than 8. Total possibilities are 10. Now at least one 5. So just count how many fives are there. This 1, 2, 3, 4 and 5. So only 5 cases will have at least one 5, right? Yes. So it is 1 by 2. So you just have to count all the possible outcomes so that the sum is greater than 8, and out of all possible outcomes, how many outcomes will have at least one 5? And just count and compute the probability. Next problem. A class has 20 boys and 30 girls. Okay. If a randomly chosen student is a girl, what is the probability that she belongs to the school's science club, given that 15 girls are in the science club? So, in a class, total students are 50. Girls are 30. Boys are 20. Right? This is the information. Now, in science club, we have 30 girls, right? 30 girls are there. Now you are picking one student at a random, and given that that student belongs to the science club. So probability of student or girl belongs to the club. Let me write, okay. Science club, given that is a girl, right? Given that the student is a girl and it belongs to science club. So how many girls are there in the science group? 15 girls. How many total girls are there in the class? 30. So what is the probability? It is just 1 by 2. So basically they are asking that if a randomly chosen student is a girl, so given that the student you pick as a girl, and she, what is the probability that she belongs to the science club? So in the science club you have total 15 girls, and picking one girl out of 30 girl is 30. Picking one girl out of this total girls are, how many total girls are there? 30. So that is the case. Okay, a family has two children. Given that at least one is a boy, what is the probability that both are boys? So if family has two children, so total outcomes could be, it could be boy and a boy, it could be boy and a girl, it could be girl and a girl, girl and a boy. Okay, these are the total possibilities with two children. Now, given that at least one is boy, so at least one is boy. What does it mean? It means now you can reduce your sample space. At least one is boy means, let me write it again. So your sample space will be having boy, boy, at least boy, boy and a girl, and girl and a boy. So your sample space has reduced to this, because extra information you got to know that at least one is boy. What is the probability that both are boy? So probability of both are boy means boy and boy, given that at least one is a boy, is boy, boy is 1, at least one boy is 3, it is 1 by 3. Simple. Next problem. A company has 60% male employee, 40% female employees. If 20% of males and 30% of female work in the finance department, what is the probability that a randomly selected finance employee is female? So you have, so total male employee you have 60%, right? Female employees you have 40%. Hmm? So 60% this, 60% that. But we are interested only in the employee in the finance department. We are only interested in the employees work in finance department. So males in finance department, FD, is how many males? 20%. Females in finance department are 30%, right? So now they are asking what is the probability that a randomly selected finance employee is a female. So probability of female, selecting a female from finance department, given that what is the probability that a randomly selected finance employee is a female? Female, given that, okay. No. Here we are interested in, okay. Here we are interested in selecting a female, given that she works in the finance department. What is this probability? So selecting a female from the finance department is, how many females are there in the finance department? 30%. So probability would be 0.3. And total employees in the finance department is 50%, right? So it is 0.5. So it is 3 by 5. Again, counting thing. So probability of male in finance department is zero point 0.2. Probability of a female in finance department is zero point 0.3. So selecting a female from the given that she works in finance department is zero point 0.3 divided by 0.5. So 3 by 5. So now these are some practice problems. Again, these practice problems you are able to solve if you watch this video. So again, let me discuss this quickly. A bag has 6 white, 4 black and 5 red marbles. If a marble drawn is black, what is the probability that the next marble is also black? We have already discussed similar problem. So total probability means total initially you have 6 plus 4 plus 5 marbles means 15, but you have already picked one and that picked one was black. So again picking a black marble means just reduce. Okay, we have already discussed. Okay, next problem. A coin is tossed twice. Okay, given that at least one head appears, what is the probability that both flips were head? So at least one head means one children wala problem we did, no? At least one heads. What does it mean? It means you will have heads and heads in the outcome, heads with tail or tail with heads. These are the cases. So probability of getting heads given at least one head. Now you just have to count. So it is 1 upon 3. We have already discussed similar problem. Next, a school has 100 students. 60 like maths, 50 like science and 30 like both. If a student likes maths, what is the probability that they also like science? So probability of math given science you have to compute. It is math intersection science divided by probability of science. Similar problem we did. So just go through the slides again. Next, a random number is picked from 1 to 50. Given that the number is even, what is the probability that it is a multiple of 5? So probability of multiple of 5 given that number is an even number. This you have to compute. So you know that how many even numbers are there between 1 to 50? 25. How many of those 20, out of 25 numbers, how many are multiple of 5? You just have to count and count divided by the total even number. That is what you have to, that will be the probability. A fair die is rolled. Okay, die problem we have already done. Given that the outcome is greater than 3, what is the probability that it is a prime number? What is a prime number? Prime number, again I have already told you, prime numbers are the numbers which are divisible by 1 or themselves. So like 2, 3, 5, 7, 9 is not, 11, these 13, etc. are prime numbers. So, when you roll a die, how many prime numbers are there? That you have to think about. And greater than 3. How many of them are greater than 3? Just count that and compute the probability. Simple. Next, a school has 200 students. If 80 students play basketball, 50 students play football, and 30 play both, what is the probability that a randomly chosen basketball player also plays football? So, probability of randomly chosen basketball player. So, given that the student plays basketball, what is the probability that he or she also plays football? So probability of football given basketball you have to compute. It is F intersection B, means probability of a student playing both the game, probability of a student playing just basketball. This you have to compute and plug in. Next, A bag has 4 red, 6 black, and 5 white marbles. Given that a randomly drawn marble is not white, what is the probability that it is a black marble? So, this one you have to do with complement rule. Not white means 1 minus white. So, probability of a white marble, or I should say probability of not white, is equal to 1 minus probability of a white marble. This you have to use to solve this following problem. A university has 1,000 students. 400 are in science, 300 in arts, and 300 in commerce. If a student is selected randomly and is from science or commerce, what is the probability that they are in science? So, what is the probability that they are in science? So, probability of if a student is selected randomly and is from science or commerce, it could be from science or commerce. What is the probability that it is? So, science or commerce means union of both. And what is the probability that they are in science? Union probability also we have discussed in the last class. So, these are the practice problem. I hope you found this video helpful.